Hello college algebra student, this video is for chapter 5.6 part 4. We continue with sketching a rational functions. So to sketch a rational function, there are a few things you need to find out. X-intercept, Y-intercept, vertical asymptote, all those things. So we're just going to go through them and then find out what happens when X approaches the vertical asymptote, so we can, find out what it look like. So the first thing is find out the y-intercept. Let's say I need to get my pencil up. So first thing is y-intercept. So y-intercept is very easy because you just plug in x equal to 0, right? So set x equal to 0. Even without factor, you can just do it right away. So you would be equal to 2 times 0 minus 0 minus 1, and the denominator will be 0 plus 1 square. So the top is negative 1, the denominator is 1, so it's equal to negative 1. So you have a point of x equal to 0, y equal to negative 1. That's the y-intercept. The second is x-intercept. So now for x-intercept, you want to factor them first. So if I factor it, I'm going to write it here. So it'll be x plus 1 square. We have a factor that's square, and then the top you have to factor it now because we have 2x squared. Remember, it is you cannot use the diamond. You would use either guess and check or AC diamond, but this is a small number, so we can just do guess and check. Okay, because 1 is the last number's factor, 2 is the first. 2x and x, it must be x or 2x or 2x and x. So what should I have? I want negative x, so I would do minus x and then plus. Because when I FOILed it out, I would have 2x squared minus 2x plus 1x. Remember, minus 2x plus 1, it would end up having minus x, and then that should work, right? So if it's a small number, you can do that. If it's a bigger number, you do AC diamond and then grouping. So the second thing is x-intercept. X-intercept is to set y equal to 0, right? Set y equal to 0, that means these two things, this whole thing, x minus 1 over x plus 1 square is equal to 0. So now there's no common factor, so you would just say, if I have a fraction that's equal to 0, that means just the numerator is equal to 0. But before you do that, check if there is any common factor. Because if there is a common factor, that cannot be 0. You want to get you ignore it first. So in this case, we have no common factor, so only the top is equal to 0. So I have 2 x-intercept. X is equal to negative 1/2, and x is equal to 1. So I would write down negative 1/2 comma 0. And 1 comma 0. So 2 x-intercept, 1 y-intercept. We have some point. And then the next thing is there any removable discontinuity? So is there any common factor that's I can cancel out? That's none, right? None removable discontinuity. No holes. 4. Vertical asymptote. So because I didn't cancel anything, so the whole vertical asymptotes would be x plus 1 equal to 0. X plus 1 square is equal to 0, actually the whole thing. So, but then that means just x equal to negative 1, just one thing. And then, and the vertical asymptote, horizontal asymptote, this is degree 2. This is also degree 2. Because x plus 1 square is x plus 1, right? So same degree, so y would equal to, the leading coefficient is 2x squared 2. The leading coefficient of this is 1. So equal to, that means y equal to 2 is the horizontal asymptote. So I write it down, horizontal asymptote. The next thing is build a table of x and y, where it is close to the vertical asymptote of negative 1. So negative 1 means what? So I can actually draw it here. X equal to negative 1 dot 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 here. And y is 2. Y is 2. draw here. And then I would have to think of close to -1. So let's say -0.9 and -1.1. So one is before -1, one is after -1. So if it's -0.9, I have to plug in here, 2 times, oh, it's really difficult, 2 times -0.9 plus 1, and then times -0.9 minus 1. Okay, and then divided by x plus 1 square, -0.9 plus 1 and square. I got 152. So I think the sign is more important. You know that if it is going to positive or negative infinity. What about -1.1? So 2 times -1.1, close parenthesis. Oh gosh, 2 plus 1 first, times -1.1 minus 1 divided by -1.1 plus 1 square. 252. So both are positive. So we have let's figure out all these points that we have. Y-intercept is 0, -1 is bound down below, and then we have x-intercept is -1/2 is here, and also 1. 1, 0. And then we have -0.9 is 152, -1.1 is 252. So this is 252. So I think it would shoot up both sides, but then this would shoot up too. So -0.9 is also 152, lower, but then it would go down to here, I think, and then go back up because the end behavior is at y equal to 2. And this is x equal to -1, right? So we can actually use decimal to check. Where's my decimal here? I have a lot of these. What was it? 2x squared minus x minus 1. X plus 1 square, right? Oh, not this. I want to get rid of these. Yeah, that's good enough. See, it is correct. So go down. Well, it's not exactly a tip here. The actually lowest point is here, but it's close. We would not know how low it goes until we learn calculus. So I think that's a good check that it is correct. Okay. So that's what it is. It's this one. So this again, we can review a little bit what we talked about in the last here. So when you do a rational function, find out y-intercept by just setting x equal to 0 and factor both numerator and denominator, finds x-intercept, and then find removable discontinuity, which is a factor of common to both numerator and denominator. That means when you plug in this number, both the numerator and denominator will be 0, so that would be a removable discontinuity. Then you find the vertical asymptote, which is a factor of only the denominator but not the numerator. So after you cancel stuff, you look at, or actually you don't just cancel, because sometimes even after the cancel, there is some factor that would make the numerator 0. And then you compare the degree to find horizontal or slant asymptote. The most difficult part is to find those points. So find those points that's next to the vertical asymptote. Usually you find one before the asymptote, one up after. Then you will know whether it's shooting up or shooting down. Okay, so that's how you graph a rational function. There's a lot of steps and a lot of terms, but if you do it step by step, you can do it. So that is all of 5.6.